I'm going to be discussing some of our tools and upcoming updates and efforts we're making towards solid form science for the 2020 to 2021 year. So to just kind of give a brief overview of where this sits within our portfolio, I'll be discussing tools that primarily come from our CSD materials, or our material science team, which focuses on the CSD materials software. This is primarily tools which are located within the CSD Python API and also within Mercury. And some of the components that you may be familiar with, we have visualization software for hydrates and solvates. We have some advanced searching tools which can be found within Mercury, such as our motif searching or packing feature search. We have conformer generation tools, methods for analyzing intermolecular interactions, such as full interaction maps. And we also offer structural property insights, such as our co-crystal design tools, our hydrogen bond propensity tools, and some of the scripts which are accessible through our CSD Python API. So a lot of the work we do in the material science team is informed through our close collaboration with some of our industry partners and what is known as the Crystal Form Consortium. So the Crystal Form Consortium, or CFC as we call it, is a sort of working group amongst the CCDC and various industry partners. It's since 2008. It's existed since 2008, and in that time we've held 11 annual CFC members meetings. We've added 6 new components to our CSD materials toolbox, which were directly sort of informed by collaboration with this group. We've made many improvements to our hydrogen bond propensity and hydrogen bond analysis workflows. And we've published 38 research papers in the field of solid form informatics. So for this upcoming year, over the next few months, we've already begun to sort of assign our priorities after some conversation with our CFC partners. And these priorities will directly lead to improvements in the software, which will then eventually become available to the wider CCDC community. Our top priority assigned after these conversations is this hydrogen bond propensity. So that'll be our primary focus for the next few months, and this includes both research and development work. We plan to update our tools to better handle sort of current pharmaceutical portfolios and the current sort of landscape of small molecules. And this includes making the tools perform better for Z prime greater than 1 structures which show intramolecular hydrogen bonding, and also larger structures that include large numbers of hydrogen bond donors and acceptors. Our next priority is on salts. So we're primarily doing research on this at the moment by exploring salts which are in the CSD and looking at what sorts of counter ions are available. We're also working on developing data sets of descriptors for the molecules of interest that may help us better analyze salts going forward. And our final priority is this non-hydrogen bonding interactions, such as aromatic analysis, which we've already introduced a tool for. This non-hydrogen bonding interactions are very complex, and there's sort of a a rich diversity in the sorts of types of structures and the types of interactions you see. So we're currently mainly focusing on internal conversations and collating feedback from both our industry partners and also some of our academic collaborators on how to better handle these sorts of interactions. Another initiative that we're currently focusing on, and this is sort of branched off from the material science team, is a methodology and a workflow approach to analyzing particles and larger conglomerates of structures. So we're going beyond the current molecular focused solid form informatics to try to bridge to the study of larger particles and also how we can tie the properties of the bulk structure to the particle and ultimately back to the molecular form. This is building off of what was previously known as the ADDOPT project. And ADDOPT stands for Advanced Digital Design of Pharmaceutical Therapeutics. This was a 4-year collaboration between the UK government, industry, and academia over the course of 2015 to 2019. And this was instigated by Medicines Manufacturing Industry Partnership, and it was partly funded by the Advanced Manufacturing Supply Chain Initiative. But this has now grown into kind of an internal project of its own. And we now have a postdoc who is working sort of full-time in this area named Alex. And it's currently studying properties such as a surface phenomenon like flow and wettability, and developing understanding of formulation and manufacturing processes. So here are some sort of things that are currently being looked into. As we have some visualization and analysis of surface properties is one front that we're currently working on, and we're also looking at the identification and analysis of potential slip planes, which is a very important aspect of larger particles. We're also working on facilitating crystal structure prediction amongst the community. And one way we're doing that is through the Crystal Structure Prediction Consortium, or the CSPC. The mission of the CSPC is to develop solutions for the storage, visualization, and management of crystal structure prediction knowledge, underpinned by community standards and driven by industry needs. As you can see from the sort of chart on the right here, it's a little bit outdated. This was from later in 2019. You can see that the number of crystal structure prediction publications has increased substantially over the last few years. So this is a very active field of research and one with a lot of evolving needs and demands from the data management people such as the CCDC. So some of our challenges to designing a CSP knowledge management solutions are we need to develop standards in data capture and standardization. And we need to find ways that we can leverage this data to gain knowledge. Like Pete said, you know, we know that a tomato is a fruit, but we should be able to say that it doesn't belong in a fruit salad. We also need to develop feature analysis in science. So we need to find ways that we can sort of leverage this data and find new ways that we can analyze it going forward. So the CSP knowledge management has sort of 5 principal components here, which work together in a virtuous circle. We have data integration, data storage, search, analysis, and results sharing. And the way that we plan to manage this from a greater sort of community perspective is we have our industry partnerships, which we also use our academic partners, our professional bodies, CSP and software providers, and the CCDC themselves, who all compose this greater CSPC, this consortium. All of these groups together work to make CSP knowledge management solutions, which then trickles down into CSP data standardization and the ultimate CSP knowledge management platform. And so we hope that all of these things working together accelerate the solutions that CSP provides. Our roadmap for our CSP knowledge management solution includes starting from Q1 of 2020 is we're planning on doing work on web access, so accessing these predicted crystal structures via the web, which flows directly into our storage and visualization solutions, which we hope to begin rolling out by Q1 of 2021. And also of note, in late Q3, early Q4 of 2020, so this year, we plan to release the blind test targets. So the blind test I'll discuss here in a moment, but just keep in mind that by late Q3, keep an eye out for these to be released. And then going into 2021 to 2022, we plan on rolling out some of our analysis and management solutions for crystal structure prediction. And also in that time period, so near the end of 2021, we plan on having the first submission back to the blind test. Oops. And so to sort of explain what the blind test I just mentioned is about. So this is a way to truly benchmark the predictive performance of CSP methods. So this is a truly blind method. The test targets are not seen by, or they can't be predicted ahead of time by any of the participants. So we select them and then distribute them. And it really helps to drive methods development within CSP by encouraging new ways of tackling the problems. And it's a good way to also inform the user community of the current state of the art by sort of revealing the results at the end. So keep an eye out for the CSP test targets to be released, and hopefully we'll see some friendly, good-spirited competition. And on that note, I will reveal the fun little activity that Carmen has been alluding to up until now. So I'm proud to announce that we have a return of the CSD leaderboard, this time in a virtual format. So if you have attended any conferences that the CCDC has been present at, you've likely seen our leaderboard script, where we take your name as it's published in the CSD, and we collate statistics based on your submissions, finally giving you a point tally. This is just a bit of friendly competition amongst friends and colleagues. So we have updated it to be a little bit more aesthetically exciting, and also to provide some more interesting, deep insights into your publication history. It's also been designed to work well with these virtual style meetings, and we we'll be here to, or I'll be here to calculate your report for you during the lunch hour if you would like it, and we can share those with hashtag CSD leaderboard and with the hashtag CCDC US UGM on social media. Carmen will be posting some of the reports that have already been calculated in the YAP, and once you have yours calculated, we can also share it via that. So at the end of the UGM, we can take a look at the final leaderboard, and you can see how you ranked compared to the other attendees. So yeah, I look forward to seeing how the competition plays out.